There is a region of Earth that almost no one ever talks about. It stretches across nearly 1/3 of the entire planet's surface. It is wider than all of the land on Earth combined, and it sits directly beneath one of the most traveled orbital paths in human history. Astronauts on the International Space Station pass over it roughly 16 times every single day. And for decades, the men and women who have lived and worked aboard that station have been looking down at it, watching it, and in some cases, reporting things that never made it into any official document. Things that were discussed quietly in the margins of conversations. Things that were described in personal journals, in private interviews, in hushed tones during press events when someone asked just the right question. This is the story of what ISS crews reported seeing over the Pacific Ocean. And if you stay until the end of this, you are going to come away with a very different understanding of what that ocean actually is, and what it might be doing. Before we go any further, if this is the kind of content that makes you lean forward in your chair, make sure you hit subscribe right now, because this is just the beginning of what we cover here, and you do not want to miss what comes next. So let us start with the basics, because you need to understand the view before you can understand what is strange about it. The International Space Station orbits Earth at an altitude of roughly 408 kilometers. It travels at approximately 28,000 kilometers per hour. That means it completes one full orbit of the planet every 90 minutes. In a single 24-hour period, an astronaut on board will watch 16 sunrises and 16 sunsets. They will see the whole planet from pole to pole, coast to coast, ocean to ocean. And in that experience, experienced astronauts will tell you, the Pacific changes you. It is not like looking at any other part of the planet. There is something about the sheer scale of it, the depth of color, the way light interacts with its surface, that becomes almost meditative for the people floating above it. But that is not what this is about. What this is about are the specific observations, the anomalies, the things that did not fit into any existing framework, that crews reported informally, and that were never formally included in mission debrief documentation. And before you assume this is going in a direction you have already seen before, stay with me, because the truth of what these astronauts reported is far more interesting and in many ways far more unsettling than any simple explanation could account for. Let us start with something that several crew members independently described using almost identical language. They called it the breathing. Now, that word was not in any official report. It came up in interviews, in memoirs, in documented conversations between astronauts and researchers studying the psychological effects of long-duration spaceflight. Multiple crew members, on multiple separate missions, described a visual phenomenon over the central Pacific at night where the ocean surface appeared to pulse, slowly, rhythmically, like it was inhaling and exhaling. The intervals were long enough that you could almost convince yourself you were imagining it, but short enough that once you noticed it, you could not stop seeing it. Several astronauts attributed it to bioluminescence, and that is a perfectly reasonable explanation. Bioluminescence in the ocean is real, it is documented, and it is spectacular from orbit. But the scale of what they were describing does not match anything currently on record. Documented bioluminescent events from orbit are usually described as faint glows concentrated in coastal regions or along known shipping lanes, where phytoplankton blooms are disturbed by vessel traffic. What several crew members described seeing over the central Pacific was different in two key ways. First, it was happening in areas of the ocean so remote that no shipping lane comes within hundreds of kilometers. Second, the scale was enormous. One astronaut described seeing what appeared to be a slowly oscillating region of dim light that covered an area larger than the state of Texas. No recorded bioluminescent event in scientific literature has ever come close to that scale in open ocean. Now here is where it gets interesting, and this is the part that the official record simply does not address. There is an area in the Central Pacific known as the South Pacific Gyre. It is sometimes called the oceanic pole of inaccessibility, Point Nemo. You may have heard of it. It is the most remote location on the surface of the Earth. The nearest landmass is over 2,600 kilometers away in any direction. It is so remote that the closest human beings to Point Nemo at any given moment are often not on land at all. They are in orbit. Astronauts on the ISS pass closer to Point Nemo than any person on the surface of Earth does. And Point Nemo sits at the heart of the South Pacific Gyre, which is one of the most biologically dead regions of the ocean. The circular current system traps water in a slow clockwise rotation, preventing nutrients from upwelling from the deep. Surface life is minimal. There are almost no fish, almost no plankton, almost nothing. And yet, multiple crew members on ISS missions have reported seeing light anomalies centered almost precisely on this region, not around it, not near it, on it, in the dead zone, in the place where almost nothing lives. This has never been formally investigated. It has never been included in any debrief documentation as a subject worth pursuing. And when crew members raised it during post-mission interviews, the conversations were redirected. Redirected is a word that comes up a lot when you start digging into this. Let us talk about another category of observation. This one is harder to explain away and harder to dismiss because it involves something that left a physical record. In 2003, a crew member aboard the ISS observed what was described as a rapidly moving disturbance on the ocean surface in the western Pacific, northeast of Papua New Guinea. The disturbance was moving in a straight line, which is unusual for any known ocean phenomenon. Ocean disturbances caused by weather, seismic activity, or surface currents do not move in perfectly straight lines. They spread, they radiate, they curve with the Coriolis effect. This did not. It moved in a straight line at a speed that the observer estimated, based on apparent ground track, at somewhere between 70 and 90 knots. A surface vessel doing 70 to 90 knots through the open Pacific would be extraordinary. The fastest conventional naval vessels in the world top out at around 60 knots, and most of those are experimental. The fastest submarines travel at classified speeds, but publicly acknowledged figures put them at under 50 knots submerged. Whatever left that track on the surface was moving faster than anything publicly acknowledged to operate in that region, and it was moving with mechanical precision in a part of the Pacific where there was nothing scheduled to be. When this observation was logged informally, the explanation provided later was that it was likely wake turbulence from a large surface vessel that had passed earlier. But wake turbulence disperses. It does not hold a straight line formation for the distance across which this disturbance was visible from orbit. The math simply does not work, and the crew member who made the observation was not a casual observer. This was an experienced test pilot with decades of experience reading surface conditions from altitude. The observation was noted. It was not included in the formal debrief. Now, you might be thinking at this point that this all sounds like a collection of anecdotes, individual observations from individual people that could each have individual explanations, and you would not be wrong to think that. That is exactly the kind of critical thinking that makes this topic worth taking seriously. Because here is the thing. When you start looking at the aggregate, when you stop treating these reports as isolated incidents and start mapping them against each other, patterns emerge that are very difficult to explain as coincidence. Let us talk about the lights. Not the bioluminescence, not the pulsing, a different category entirely, what several crew members described as lights that moved against the grain. At night, from orbit, the Earth below is a patchwork of darkness and light. Cities glow like orange and white nebulae. Highways trace thin, luminous threads across continents. Fishing fleets cluster in the productive waters off the coasts of Japan, South Korea, Peru, Chile. You can see all of it from up there. You can tell a lot about human activity on Earth just by reading the light patterns at night. But the Pacific at night, in its deepest regions, is dark. Genuinely dark in a way that almost nothing else on Earth is dark anymore. No cities, no roads, minimal shipping. And so when a light source appears in that darkness, it stands out with extraordinary clarity against the black surface of the ocean. Multiple crew members on separate missions reported seeing point sources of light in the deep Pacific that behaved in ways inconsistent with any known vessel or aircraft. The primary anomaly was direction. Fishing vessels move slowly and generally maintain course. Container ships follow predictable lane routes. Aircraft crossing the Pacific follow great circle routes that are well established and visible on any navigation chart. What crew members reported were lights that moved in directions that did not correspond to any of these patterns. Lights that turned sharply. Lights that accelerated from apparent stillness to rapid movement. Lights that disappeared not by moving out of the field of view, but by simply ceasing to be visible, as if they had submerged or extinguished instantaneously. One account, given by a crew member during an informal conversation that was later partially transcribed in a researcher's notes, described watching a light source over the deep central Pacific that moved in a slow arc across the surface for several minutes before stopping completely. The observer watched it for what they estimated to be another 3 to 4 minutes in a stationary position. Then it moved again, this time in a completely different direction, faster than before disappearing. The entire sequence lasted roughly 10 minutes, and the light source covered a distance the observer estimated at several hundred kilometers. No surface vessel, no submarine, no known aircraft makes those kinds of maneuvers at those kinds of speeds in the middle of the Pacific Ocean. And yet the observation sits in a notebook and not in any debrief document. Here is the part that I think is the most important piece of this entire conversation, and it is the part that almost never gets discussed. The question is not just what these crews saw. The question is why these particular observations were systematically excluded from formal documentation. And the answer to that question is actually more revealing than any single anomalous sighting could be. Astronaut debriefs are comprehensive. They cover everything from medical data to equipment performance, to psychological state, to interpersonal dynamics within the crew. They cover meals and sleep and exercise. They cover every scientific experiment conducted during the mission. They are extraordinarily thorough documents. The idea that specific visual observations made by trained observers during their orbital passes would simply be omitted by accident is not credible. These are not people who forget things. These are not record keepers who leave sections blank by mistake. When something is not in the debrief, it is because a decision was made that it should not be in the debrief. Now, there are several possible reasons for that decision. The most charitable is that observations which cannot be explained and cannot be verified are simply not included because they add noise to a technical document meant to inform future mission planning. That is a reasonable institutional response. You do not want your mission debrief filled with subjective observations that have no actionable follow-up. So you filter them out. You address them through other channels. You note them informally and move on. But here is the problem with that explanation. Several crew members have stated in interviews that they were specifically discouraged from pursuing these observations. Not gently redirected, actively discouraged. Told that these were not the kinds of things that should be discussed publicly. Told that if they had further observations of this type, they should report them through specific channels that were separate from the standard debrief process. Separate channels for specific observations over the Pacific. That is not bureaucratic filtering. That is institutional compartmentalization, and compartmentalization exists for a reason. It exists because whatever is being compartmentalized is considered sensitive enough to warrant separation from general record-keeping. So what could it be? Let us go through the possibilities, seriously and methodically, because this is where things get genuinely fascinating. The first possibility is military operations. The Pacific is the most strategically significant body of water on Earth from a military standpoint. The United States, China, Russia, Japan, Australia, and a dozen other nations operate military assets in the Pacific at all times. Many of those operations are classified. Submarine activity in particular is a closely guarded domain. It is entirely plausible and in fact quite likely that some of what ISS crews observed over the Pacific represents classified military operations that program administrators did not want documented in publicly accessible debrief records. This explanation accounts for some of what was reported. It does not account for all of it. The scale of the bioluminescent type phenomena, for instance, does not fit any known military operation, and the behavioral characteristics of some of the observed light sources exceed what any publicly acknowledged military platform is capable of. If those capabilities exist in classified programs, they are classified at a level that would make even acknowledging their existence in a debrief document a significant security concern. So the military explanation covers some of the ground, but not all. The second possibility is natural phenomena that are not yet understood. The deep ocean is, genuinely and without exaggeration, the least understood environment on Earth. We have mapped more of the surface of Mars than we have mapped of the ocean floor. We have explored less than 20% of Earth's oceans in any meaningful detail. The Pacific, in its deepest and most remote regions, is essentially a scientific terra incognita. What happens down there? What processes occur? What biological or geophysical activity takes place at depth and propagates to the surface is largely unknown. Bioluminescence at massive scale is not outside the realm of natural possibility. The ocean contains organisms capable of producing light, from single-celled phytoplankton up to large cephalopods. A coordinated bloom event of sufficient scale could, theoretically, produce surface lighting effects visible from orbit. Whether those effects could produce the oscillating, pulsing, directionally consistent patterns that crew members described is a much harder question to answer. And the honest answer is that we do not know, because we have never looked. Because the remote Pacific is so inaccessible and so poorly studied that the data simply does not exist to confirm or deny these observations through a natural lens. What is notable is that rather than using these crew observations as a starting point for investigation of unknown natural phenomena, they were simply removed from the accessible record. If these were natural events worth studying, the appropriate response would have been to flag them for oceanographic follow-up. Instead, they were compartmentalized, which suggests whoever made that decision either already knew what they were or considered the question of what they were to be above the pay grade of oceanographic inquiry. The third possibility is the one that everyone gravitates toward immediately and the one that serious researchers approach most carefully, that some of what was observed represents technology or activity that does not have a straightforward conventional explanation. Now, here is where I want to be precise, because precision matters. When crew members describe light sources moving at speeds exceeding any known platform, turning sharply without decelerating, disappearing instantaneously into or below the ocean surface, the data-honest response is not to immediately leap to any particular conclusion. The data-honest response is to acknowledge that the observation, if accurate, describes something that does not match any publicly known technology or natural phenomenon. That is the honest starting point. Whatever the explanation turns out to be, the observation represents a gap in our understanding. And gaps in our understanding of the Pacific are not trivial, because the Pacific is not just big. It is deep in ways that most people never fully internalize. The average depth of the Pacific Ocean is roughly 4,000 meters. 4 kilometers of water column, on average, everywhere you look. The deepest point, the Challenger Deep in the Mariana Trench, reaches down to approximately 11,000 meters, 11 kilometers below the surface. The pressure at that depth is over 1,000 times the pressure at sea level. The temperature hovers just above freezing. It is permanently dark. And we have sent human beings there exactly a handful of times in all of recorded history. The Mariana Trench, notably, sits in the western Pacific, directly beneath one of the most commonly described anomaly regions in ISS crew accounts. This is not necessarily causal, but it is a geographic fact worth noting. What lives at those depths is still largely a matter of speculation. We know that life exists there because every time we have managed to send a probe or a submersible down to extreme depths, we have found it. We keep finding life in places where we were certain life could not exist. At hydrothermal vents where the water temperature exceeds 400 degrees Celsius, organisms thrive. In the crushing darkness of the abyss, ecosystems exist that we are only beginning to document. The deep Pacific is not empty. It is full of things we do not understand. And the surface of the deep Pacific, the part that ISS crews can actually see from orbit, is connected to all of that depth by a water column that we have barely begun to study. When crew members see something moving on or just beneath the surface of the remote Pacific, moving in ways that suggest intelligence or technology, the question of what lives in that water column becomes suddenly very relevant. Because the Pacific, unlike any other ocean, has the physical dimensions to conceal things that we have never imagined concealing. Let us come back to the crew accounts, because there is another category of observation that has received even less attention than the lights and the surface disturbances. Several crew members, across multiple missions, described what they called structural features visible beneath the surface in certain regions of the Pacific under specific lighting conditions. Now, this requires some explanation of the physics involved, because it is actually a well-documented optical phenomenon. When light hits the ocean at a low angle, as it does near the terminator line, the boundary between day and night on Earth's surface, it penetrates the water column differently than it does at high noon. Under these conditions, depending on water clarity, surface texture, and depth, it is sometimes possible to see features on or near the ocean floor in relatively shallow water from very high altitude. This has been used in aerial and satellite archaeology over the Mediterranean and the Red Sea to identify submerged ancient structures. The physics are real. In the Pacific, water clarity in certain gyre regions is extraordinary. The South Pacific Gyre, in particular, has some of the clearest water on Earth because its biological dead zone means there is almost nothing in the water to scatter or absorb light. Under the right conditions, at the right orbital angle and sun angle, it is theoretically possible to see deeper into the Pacific water column from orbit than from any other vantage point. What crew members describe seeing in these conditions has never been formally catalogued, but the descriptions that have surfaced through interviews and informal accounts share some common characteristics. Linear features, features with right angles, features that appear at consistent depths across wide geographic separations, features that do not correspond to known volcanic structures, known ocean ridges, or known seafloor topography. Now, here is where I need to be careful, and where I want you to be careful too. The human eye is extraordinarily good at finding patterns, including patterns that are not really there. Pareidolia is real. We see faces in clouds and shapes in static. And an astronaut looking down at the ocean floor through kilometers of water column, under unusual lighting conditions, after weeks of sleep deprivation and sensory disruption, is potentially primed to perceive pattern and structure where only geology exists. That is a legitimate counter-argument, and it deserves to be stated clearly. But here is the counter to the counter. The people making these observations were not casual observers having a moment of wonder. They were trained scientists and engineers. Many of them were military pilots with thousands of hours of experience reading terrain and surface features from altitude. They know what natural geological structures look like from above. They know what a ridge looks like, what a volcanic formation looks like, what a fault line looks like. When one of these individuals says that what they observed did not look like natural geology, that statement carries more weight than it would coming from an untrained observer. And several of them said exactly that. There is one account in particular that stands out, and I want to walk through it carefully because it illustrates everything I have been describing in the most concentrated form. During a long-duration mission in the early 2010s, a crew member with a background in geology and extensive experience reading geological features from aircraft was conducting a routine Earth observation session. These sessions were a regular part of ISS operations. Crew members photograph surface features, weather systems, geological events, agricultural patterns. It is a scientifically valuable activity, and it is also one of the few recreational pleasures of living in a metal box at the edge of space. You get to look at Earth. On this particular pass, the station was crossing the Central Pacific on a trajectory that brought it over the deepest, most remote section of the ocean, south of Hawaii and north of the equator, in the early morning light. The sun angle was low, water clarity in the region was high, and the crew member, looking down with a camera equipped with a telephoto lens, observed something that they later described in detail in a personal account that has circulated within a small community of researchers. What they described was a series of what appeared to be large, dark, rectangular forms visible beneath the ocean's surface at what they estimated to be a significant depth. The forms were arranged in a pattern that was difficult to interpret, but impossible to mistake for random geological formation. They were consistent in size, they maintained regular spacing, and they were oriented along a common axis. The crew member took photographs. Those photographs, according to their account, were subsequently handled through a process separate from the standard mission photography archive. They did not appear in the publicly accessible database of ISS Earth observation images, where essentially everything else ends up. The crew member did not press the issue. They understood the system they were operating in. They moved on. But they remembered what they saw. And years later, in a context where they felt they could speak more freely, they described it. Are those photographs still in existence somewhere? Almost certainly yes. Are they accessible? Clearly not. What were those rectangular forms? That question does not have a clean answer, but the fact that the documentation chain for those images was handled differently from standard mission photography is itself a piece of data. You do not treat ordinary geological observation photographs differently. You treat differently the things you consider sensitive. Now let us zoom out for a moment and talk about the broader context of what we know about the Pacific, because context matters enormously here. The Pacific Ocean Basin is the oldest oceanic basin on Earth. The Atlantic is relatively young in geological terms. The Indian Ocean is intermediate, but the Pacific Basin contains seafloor that has been accumulating for over 200 million years. Some of the oceanic crust beneath the Pacific has been sitting there, slowly moving, since before the age of dinosaurs. And that means that the Pacific seafloor contains a geological record that is unlike anything else on the planet. It also means that the Pacific seafloor has had time, enormous amounts of time, to be shaped by every kind of geological process imaginable. Volcanic activity, tectonic movement, hydrothermal venting, submarine landslides, the accumulation of sediment layers hundreds of meters thick in some places. All of this has been happening for 200 million years, in a basin that we have only seriously begun to study in the last few decades. We do not know what is at the bottom of the Pacific, not really. We have bathymetric maps that give us a general picture of the seafloor topography, but the resolution of those maps is, in most regions, comparable to what you would get looking at a mountain range through a window from a moving train. You can see the big shapes. You cannot see the details. This matters because it means that any claim about what is or is not possible on the Pacific seafloor needs to be made with genuine humility. We are not in a position to say definitively what is there and what is not there. Our maps are too coarse, our direct observations too sparse, and our theoretical frameworks too incomplete. When ISS crew members describe seeing things beneath the Pacific surface that do not fit conventional categories, the honest scientific response is to say, we need better data. Not to say this is impossible. The word impossible requires a level of knowledge about the Pacific that we do not possess. Let us talk about another observation type that comes up repeatedly in the informal accounts and that points to something genuinely puzzling. Atmospheric phenomena over the Pacific that crew members described as behaving differently from equivalent phenomena over other ocean regions. The Pacific is the world's largest weather engine. The temperature differential between the cold Humboldt Current running up the South American coast and the warm waters of the Western Pacific drives weather patterns that affect the entire planet. The El Niño and La Niña cycles, which reorganize global precipitation patterns, originate in the Pacific. The jet streams that govern the weather of the Northern Hemisphere are shaped by Pacific temperature dynamics. From orbit, watching weather systems form and move over the Pacific is a significant part of what crew members observe. They become, over weeks and months of orbital passes, extremely familiar with how Pacific weather systems look and behave. And several crew members have described, in informal contexts, seeing weather formations over the Central Pacific that did not behave the way they should. The most specific accounts involve something that meteorologists who study satellite imagery call anomalous atmospheric circulation patterns. These are regions where the normal rotation of storm systems, governed by the Coriolis effect, appears to be locally disrupted. From orbit, these appear as areas where the visible cloud patterns are swirling in a direction or at a rate inconsistent with the surrounding system. They are rare, and when they occur over land or in well-monitored ocean regions, they attract scientific attention. Over the remote Pacific, where monitoring is sparse, they are less likely to be caught by automated systems. But from the ISS, with a human observer watching in real time, they are visible. And crew members have described seeing them in regions of the Pacific that coincide, geographically, with other categories of anomalous observation. Now, anomalous atmospheric circulation patterns have known causes. They can be driven by strong temperature differentials at the ocean surface. They can be driven by unusual ocean current behavior. They can even be produced by large underwater geological events, such as submarine volcanic eruptions that heat the water column and affect the atmospheric layer above. All of these are natural explanations. But they can also, theoretically, be produced by large-scale energy release at or below the ocean surface. Any significant energy release, whether thermal or electromagnetic, that is concentrated enough and sustained enough will affect the atmosphere above it. This is well-established physics. The surface of the ocean and the atmosphere above it are in constant thermal exchange, and anything that disturbs the ocean surface significantly will leave an atmospheric signature. If there is something in the deep Pacific that is releasing energy at scale, that energy would show up in the atmosphere. It would show up as exactly the kind of anomalous circulation patterns that crew members have described. That is not a claim about what the energy source might be. That is just physics. The atmosphere tells you things about what is happening below it, if you know how to read it. And trained observers in orbit, who have spent months watching the Pacific atmosphere evolve, are arguably in the best position of anyone to notice when something is out of place. The question that keeps surfacing when you sit with all of this is why the Pacific specifically? There are other vast, remote oceans. The Southern Ocean surrounding Antarctica is arguably more remote in some ways. The Indian Ocean is enormous. The North Atlantic is frequently described as hostile and difficult. Why does the anomalous observation cluster concentrate so heavily over the Pacific? Part of the answer is orbital mechanics. The ISS orbital path gives crews a slightly better view of mid-latitude Pacific regions than some other remote ocean areas, simply because of the inclination of the orbit. More passes, more observation time, more opportunity to notice things. That accounts for some of the statistical skew. But the Pacific is also genuinely different from other oceans in ways that go beyond size. The Mariana Trench is the deepest known point on Earth's surface. It is in the Pacific. The majority of Earth's subduction zones, where tectonic plates dive beneath each other, are in the Pacific. The Ring of Fire, the chain of volcanic and seismic activity that borders the Pacific, represents the most geologically active region on Earth. The Pacific holds more of Earth's tectonic energy, more of Earth's geological dynamism than anywhere else, and its water column, in those central gyre regions, is among the clearest and most biologically sparse on the planet, which paradoxically makes it both harder to see through at scale and easier to see through under specific conditions. If something unusual is happening beneath the ocean, the Pacific has the geological dynamism to generate it, the depth to conceal it, and the clarity to occasionally reveal it to an observer with the right vantage point. There is one more category of observation that I want to address before we start pulling all of this together, and this one is the most difficult to discuss, because it is the one that is most easily dismissed, and simultaneously, the one that crew members have described most consistently. Several astronauts, when speaking candidly outside of formal contexts, have described the Pacific as feeling different, not in a mystical sense, not in a way they could fully articulate or that they were entirely comfortable discussing, but a recurring description across multiple crew members from different missions, from different national space agencies, with different cultural backgrounds and different personal dispositions, is that extended observation of the Pacific from orbit produces a qualitative experience that is different from observing any other region of the planet. Some described it as a sense of depth that went beyond the visual, a perception of something vast and layered, not just the ocean but whatever exists in and beneath it, that impressed itself on the observer in a way that other geographic regions did not. Several described feeling what they could only characterize as observed, not in a paranoid sense, but in the way you feel when you are looking at something that is also, in some way, registering your presence. Now, I want to be very clear about what to do with that information. Subjective psychological experience, particularly the subjective psychological experience of people living under extreme conditions of isolation, confinement, sleep deprivation, and novel perceptual input, is not reliable primary data. It is not science. It tells you something about the experiential state of the observer, but it does not tell you anything definitive about the thing being observed. However, when a dozen or more people, independently, with no access to each other's accounts, using similar language, describe a similar qualitative experience in relation to a specific geographic region, that convergence is itself a data point. It does not prove anything about the Pacific, but it tells you that there is something about observing the Pacific from this particular vantage point that consistently produces a specific type of qualitative response in trained, experienced observers. And the question of what is generating that response is worth asking. The most mundane explanation is perceptual. The Pacific, being so vast and so uniformly empty, provides a visual experience with fewer reference points than any other surface feature. No roads, no cities, no coastline variation, just an endless expanse of blue. This could produce a qualitative sense of depth and openness that is purely a function of visual processing and has nothing to do with the Pacific being anything other than a very big ocean. The less mundane explanation is that the Pacific, being in fact the location of something that does not fit into conventional categories, is producing an effect on observers that is more than purely visual, that the thing, or things, that crew members have observed as light anomalies, surface disturbances, subsurface features, and atmospheric irregularities, is large enough or energetically significant enough to produce a perceptible field effect that trained human observers pick up on without being able to fully specify what they are picking up. That is a much harder claim to evaluate, but it keeps appearing in the accounts, so it needs to be acknowledged. Let us talk about what happens after. Astronauts who return from long-duration missions on the ISS go through an extensive post-mission process. Medical evaluations, rehabilitation for muscle and bone loss, psychological support, and the debrief. The formal mission debrief is a structured process conducted over multiple sessions by teams of specialists covering every domain of the mission. It is thorough and it is documented. And then there is the informal debrief, the conversations in hallways and cafeterias and over video calls with colleagues and friends. The things that get discussed outside of the formal process. The things that crew members tell each other but not the room, with the cameras and the official record keepers. Multiple sources who have had access to these informal conversations have described a consistent pattern. Crew members return from missions and compare notes with each other privately. And the Pacific comes up. The lights come up. The pulsing comes up. The things that moved in straight lines. The things that appeared and disappeared. And then the conversation shifts because of an unspoken understanding of what gets discussed in which context. This is not a conspiracy. It is not a cover-up in the dramatic sense. It is something more ordinary and in some ways more frustrating than that. It is institutional culture. It is the implicit understanding that certain observations belong in certain channels, and that going outside those channels creates problems you do not want to have. It is the pragmatic calculation that your career, your credibility, and your future flight opportunities are more valuable to you than the public discussion of something you cannot explain and cannot verify. So people stay quiet, or they speak carefully, or they wait until they are no longer active crew members and have less to lose. And the observations that never made it into the mission debriefs accumulate in the margins of the record. In journals, in interview transcripts, in letters, in conversations that researchers piece together years after the fact. The aggregate picture that emerges from all of these accounts is not of a single phenomenon. It is of multiple, overlapping categories of observation that share a geographic focus, a quality of anomaly, and a pattern of institutional non-acknowledgement that is itself a data point. Something is happening in the Pacific. Multiple experienced observers have seen it from multiple different missions across multiple different decades. It does not fit neatly into any known natural or technological category. And the people who are positioned to formally document it have consistently chosen not to. The Pacific covers more than a third of the surface of the Earth. It is on average 4 kilometers deep. In its deepest regions, it is 11 kilometers deep. It is, in terms of sheer volume of unexplored space, the largest unknown environment that human civilization has ever existed alongside. We have spent a century and a half exploring its surface, its shallows, its coastlines. We have barely begun to understand what lives in its middle depths. And its abyssal zones, the vast dark plains that cover most of its floor, are as alien to us as the surface of Europa. Whatever is down there, whatever processes are happening in that darkness, whatever might be using that ocean as a medium or a habitat or a concealment, we are not in a position to rule things out. Our ignorance of the deep Pacific is not an embarrassing gap in an otherwise complete picture. It is a foundational condition of our understanding of this planet. We do not know what the Pacific is. We know what its surface looks like from above. We know some of what moves through its shallower regions. We do not know what lives at its bottom, what energy processes occur at its floor, or what might exist in the water column that we have never documented because we have never adequately looked. What ISS crews have seen over the Pacific, the things they talked about in corridors and wrote in personal notes, and mentioned carefully in interviews, and never said in debriefs, those observations are not proof of anything specific, but they are something important. They are observations made by the most qualified human observers ever positioned to observe that ocean, from the best possible vantage point, under conditions that allowed them to see things no surface-bound observer could see. And the fact that those observations were consistently and deliberately excluded from the formal scientific record of human spaceflight should make you ask questions, not just about what is in the Pacific, but about what we decide deserves to be known, who makes that decision, and what the cost of leaving those gaps in the record might eventually turn out to be. Because the Pacific is not going anywhere. It will still be there tomorrow, and the day after. The ISS will continue its 16 daily passes over that enormous expanse of water. Future crews will press their faces against the observation windows and watch the blue go by. And some of them, if the pattern holds, will see things they will not know what to do with, things that will not make it into any official document, things that will join the long, quiet archive of what trained human observers have seen from orbit and decided, or been told, not to say. The Pacific has been keeping its secrets for 200 million years. Whatever is down there is very good at waiting, and we are only just beginning to understand how little we know.